So today we're talking about the ambiguous case. This involves what we did yesterday, and what did we do yesterday? Does anybody remember? We did the law of sines. Let me give you something. Let me give you something that gives away this question. All right. If on your Regents exam you see this wording in the question, how many distinct triangles, you automatically have to do this process, and we're going to do it right now. How many distinct triangles can be made? Let me give you the options. There are three options. There's either 0 triangles that can be made, 1 triangle that can be made, or 2 triangles that can be made. Right? That's it. That's always. There's only 3 options: 0, 1, or 2. Okay? And so what we're going to do is we're going to run through all three scenarios. And then if you want, we'll come back, we'll talk about why I chose them in that order. Okay? So the first scenario, what do? We got to draw a picture. Let's do that. Starts off the same way. It's triangles, right? Didn't say what kind of triangles, so you can't assume they're right. It's A, B, and C. Let's do this. This is going to be A. This is going to be B. This will be, oh, hold on. Sorry about that, because I want to use my notes. This is going to be B, this is going to be C, this is going to be 30 degrees, just reading the directions, and so side A is going to be 20. This is angle C, right? We don't know how much it is, but we do know that side C is opposite and it's 16. So how many distinct triangles can be made? Do you know anything about B at all? You don't know anything about B, true? Do you have enough information to try and find C? Yes. Let's try and do that. So what do? Yeah. We do the exact same thing as yesterday. Sine of A over A equals the sine of C over C. Whoops. Let's see. The sine of 30 degrees over 20 equals the sine of C over 16. Yep, we're going to cross multiply it up. And everything's going real smoothly, right? Okay, everything's going real smooth. You know, we're doing this. 16 times the sine of 30 equals 20 times the sine of C. Does everybody have a calculator? If you don't have a calculator, go get one. I'm going to pause. Even I had to get my own calculator, right? I'm now going to divide both sides by 20. Divide by 20. Divide. Right? I'm going to, if you don't mind, actually, you know what? Let me just write it out. Keep it on that side. So 16 times the sine of 30 degrees divided by 20 equals the sine of C, right? We're trying to find out the angle, so what do we have to use, Lil? We're going to have to use arc sine, or inverse sine as you want to call it. So sine inverse, you always use the inverse when you're looking for an angle, of 16 times the sine of 30 divided by 20 equals C. How much does C equal? Let's see. Oh, you always do sine -1 when you're looking for an angle. You know, I'm trying to find angle C. You got to use the arc sine. That's what it's called. So let me just, my calculator, I got to make sure it's in degree mode. I'm now going to type in 16 times the sine of 30 degrees divided by 20. Good. Second sine of the answer is, and I'm just going to round that to 24, right, to make life easy. Okay. So let's talk for a minute. Everything went real smoothly? Did I hit any speed bumps along the way? No? Nope, not at all. Let's go dual screen for a minute. So let me draw up my triangle. It's a huge triangle. That's A. This is C. And this is B. I'm just drawing it up because I want to show you something. The side C was 16. A was equal to 20. Oh, come on, computer. A is equal to 20. Angle A was 30 degrees. How much did we find out angle B was? I'm sorry. Angle C was how much? Okay. This is 24. So how much is this angle? 126. And did I make a triangle that works? Okay. So since we hit no speed bumps along the way, what I'm telling you for right now is one triangle is possible. Now, I know what you're thinking. I told you that there were 3 particular scenarios, right? There was a scenario that you're going to see where there are no triangles possible, and another one where there are 2 triangles possible. All I want to show you for right now is that if you are able to do the problem and it works out smoothly like this, one triangle is possible. Okay? So one triangle is possible. That's it. That's all you have to know for right now. Do you accept that? Good. Now just hold tight for the rest. We've all agreed we're going to accept this for the time being. And now, so let's play again. Let's play again. Do you see? It looks exactly like the question that you were just asked. Right? It looks exactly. It even says how many distinct triangles can be made. Same thing. Let's play. Let's play. Up. What do you think happens? Do you think anything changes? Nope. We draw a triangle. I'm purposefully talking like this to show you that nothing changes. Draw the triangle. We label it up. Angle A is 30. Well, this is almost kind of boring. You know what I'm saying? Side C is 16. Side A is 7. Same thing. That's lowercase. Nope. That's a lowercase. My bad. My bad, Lil. My bad. Lowercase c. Up. Same thing as before. What do you think we're going to do? Yep. You know it. Hold on 1 minute, Henry. Hold on 1 minute. It's not bad. That's not bad. Nope. You're not going to have to erase it. I just want to show you something. Now watch. Everything is going according to plan, right? Same as before. We're going to fill it in. Sine of 30 over 7 equals sine of c over 16. Oh, let's try. Let's see what happens. Keeps going. Same thing as before. 16 times the sine of 30 degrees equals 7 times the sine of c. Divide both sides by 7. Same as before, right? Okay. So we got 16 times the sine of 30 over 7 equals sine of c. Now, who asked me before? How do you find an angle measurement? What's that called? It's called the arc sine. Okay. So we got the arc sine of 16 times the sine of 30 all divided by 7 equals c. And it turns out when you try and plug this into your calculator, let's see, 16 sine 30, enter, divided by 7. Now let's do inverse sine of the answer. Okay, we got an error. Guess how many triangles are possible? 0. Is that difficult to understand? Why doesn't it work? No. Why doesn't it work? At its very core, what does the sine of an angle represent? What's the ratio? It's OH, right? It's opposite side over the hypotenuse. And so if you get a number bigger than 1, which one of those numbers is bigger, the top or the bottom? The top, right? How can that be the case? The hypotenuse is always the longest side of a triangle, and therefore it just doesn't work. A triangle cannot be formed by these measurements. You okay with that? Speaking of this, right, let's talk about a basic idea in a triangle. The biggest side is opposite the what? The biggest angle. What about the medium side? Opposite the medium angle. What about the smallest side? Keep that in mind when we're going to do the next one. All right, guys. What do you think we do? Anything different? Same thing as before. It looks exactly like the questions that you've been asked. So we're going to do the same process. Draw up our triangle. Let's see. This is going to be C. I'm going to switch it up a little bit. That side is going to be A. This side is going to be B. Is that bad?
Yeah.
Really? Okay, all right. Okay, I'm going to be honest with you. It does not make a difference. You guys don't like it switched up. So which one goes in the bottom left corner? What do you want down over here? What do you want up top? What about over here? Okay, all right. So this is going to be 30 degrees. How much was side A? A was 10. How much was side B? B was 16. Okay. We don't know anything else, right? So what angle do you think we're going to try and figure out? Okay, B. Do you think it's going to work? Maybe. I don't know. Maybe. Let's see what happens. Let's go do the same thing. So sine of B over B equals sine of A over A. We have no idea how much the sine of B is, but side B was worth 16. This is going to be sine 30. This is going to be 10. Yeah, man, 30. Set it in the directions. Said A was 30. Henry?
Yeah.
Henry, cross multiply, right, buddy? Okay, all right, hold on. All right, okay. We got to go. All right, 16 times the sine of 30. Divide both sides by 10. We get sine of B. This is the same thing we've been doing, right? Same thing we've been doing. Over 30. We're looking for angle B. Oh my God. Yep. Sine inverse of and we plug this into our calculators, right? Yep, I think so. So what's different? Whoops. It's looking like it before, but the last time this worked out, right? How many triangles did we get? No. The last time it went real smoothly like this, we got one triangle. So why am I telling you that there could possibly be another? I'm going to round that to 53. Okay. All right. Okay. Now let's go back. Whoops. Here's what I'm saying to you. Let's draw it in. This is A. This is B. Whoops. This is C. And so this is 30 degrees. We found that this was 53 degrees. 53. And, yep, if you made the calculations, right, 180 minus 53 minus 30 is how much? 97. Because how many degrees are there always in a triangle? Okay, all right. And did we know how much the other sides were? This was 6. This was, how much was side A? This was 10, and this was how much? Side 16. And so now here's what I'm saying to you, okay? If there was another triangle possible, here's what makes it possible. Do you know anything about angle C? Do you know anything? No, from the directions. Do you know anything about C? Does it lock it in place? Does it lock its side in place? So C is free to move about to accommodate however big B is. Do you see that? Okay. All right. And right now everything is also still working out. B turned out to be bigger than A, and its side is bigger than A. So everything according to triangles is working out. Now watch this. We're going to take down some notes, and I'm going to show you in your calculator that something weird is going to take place. Okay? Here's what I'm saying to you. Here's what I'm saying to you. There's a rule, all right? What is the other possible triangle I could be talking about? Well, it turns out there's another option for B. Okay? There's another option for B. How much is 180 degrees minus B? Whoops. That's 180 degrees minus the amount we found for B, which is 53, which is 127. Okay? And watch this. Right? It turns out that the sine of 50, what was it, 53? Type that into your calculator. That's the original amount we found for B. Type in sine 127. They're the same thing, which means 127 is another possible measurement for B. Where the 127 comes from is from circular trigonometry, which we're going to explore in 2 weeks' time. All right? But this is really easy to remember. 127 is another possibility for angle B. But will it fit in the triangle? Let's see. 127 degrees is another possibility. Well, we're going to find out. So here's what I'm saying. So 127 is another possibility for angle B. It was a hidden option. It's found by doing 180 minus 53. All right? But we have to check whether this other hidden option for B, right, instead of it being 53, it being 127, will still fit in the triangle. Right? So all you do is redraw your triangle again. Right? Here's angle B. Here's angle A, here's angle C. Remember what we talked about C? C was never locked in place. It never had a side that went with it. So if you increase, the only one that was locked in place was A at 30. If you increase B's size to 127, what would theoretically happen to C? It would shrink, but is there room for it to shrink? Yes. What would angle C be? 23, right? Is that a triangle? Does it add to be 180? Perfect. That's the other triangle that's possible. Okay, the sides still fit in. I think this was 10 and this was 16. You don't know what side C is, but it really doesn't matter. You could find it out. This is the answer. If it works, 2 triangles are possible. It's like a secret triangle. Yeah. Okay. So 2 triangles are possible. Did everybody get this down, or are people still copying? Let's go back to question number 1. Let's go back to question number 1. Let's go back to question number 1, right? I'm just scrolling through my notes. Right? So question number 1, notice we did all of this work right here. And I didn't show you all that complicated business at the end of question number 3, right? So you got C is 24. What's the hidden possible option for C? Right? The hidden possible option is simply is simply 180 minus 24, which is what? 156. But A was locked in place at 30. And if you tried to put 156 in for B, what happens? Why won't it work? Because it's 186 is too high. There isn't anything left over for C, no matter how small it shrinks. And that's why there's only one possible triangle available. It's exactly the case. Every time there's one, you have to check to make sure the hidden one, the other one, is there. You good?
So the sine